Hello, developers. So, we are here for a discussion on one of the very important principles of the solid principles. It is the dependency inversion principle. It is a very simple one, yet a lot of questions are asked around it, and people tend to get confused. So, today we'll go beyond definition and we'll understand why it is there in the first place and what is the use of the dependency inversion principle, why you should use it. Okay, so before we start, I'll give you an example. So suppose you work for a restaurant. You are designing a software for a restaurant and you are designing a billing system. Now what happens is the application is ready with the bill and you want to get the bill printed. All right. So now you do not care from the system which printer is being used. Or rather, you should not be concerned until unless the bill is getting printed. So you just say print the bill, a printer is used, and the bill comes up. If you see this system, billing is a high level component, printer is a low level component because the billing is something that you're concerned about the most. You do not care whether printer changes or what happens with the printer until unless you're getting the output. But billing is the core functionality here. So billing is the high level module and printing is a low level module in context of this example. Okay, so let us start writing the code for this particular example. So I'll just ignore the main method for now. We'll use it to create objects and you know do the actual functionality. Okay, so suppose you have a class which says invoice generator, and as the name suggests, it is responsible to generate invoices. So you have a method here, print generate invoice, and you need to pass some details of the invoice, which for the simplicity of this example will keep it as string, but definitely you will have some model of a bill which will be passed as an object, but for the simplicity we'll keep it as string. So suppose I'll name it as string bill details. What this does is it will be responsible to print the bill. Okay, fine. Now suppose we have another class which is supposed to do the actual printing. Okay, and it is a matrix printer. Matrix printers are the dot matrix printers that were used, previous in the older days in the sense, not so older days, but yeah, those are kind of outdated now, right? So let me say that this public void not return anything. It will simply print the invoice based on whatever bill details you give this, right? Okay, so we have an extra parenthesis. Yeah, so for it will do some printing activity, but for the sake of simplicity, we'll simply say it is printing the things, printing using a matrix printer. Hmm? Matrix printer, and just so that we know, and give the bill details as well. Yeah, bill details, right? We have better ways of handling strings, but I'm not going into those things now. You also have a laser printer in your system, right? Which is being replaced, for example, slowly. No one is using it much, but in the long run, you will be using the laser printer. So what we'll do, the laser printer also has a method to print because definitely it will also print. But what is the difference? It will have a separate use case or separate way of printing it, not the use case but a way of printing. Use case is same. It will print, it will take the bill details and it will print the bill, right? So similarly we'll just say console dot write line print using laser printer, and just for the sake of it I'll keep the bill details. All right. Okay, so we have two printers who does the job. This is your invoice generation. Invoice generator is supposed to is a high level module. Okay, invoice generator is supposed to simply print the bill. So it will say, printer, please print the bill. So what it will do, it will just get the objects. So suppose it is printing using the matrix printer, right? Dot print invoice. It will pass the bill details. Fine. Okay. Now somewhere we have a main function which is responsible for, calling the methods. So I have, okay, why am I, okay, invoice generator, mhm, new invoice generator. I'm using invoice generator dot generate invoice, and let's say this is, or rather, bill number one. Just for the sake of simplicity, will not, and I'll have add more complexity here. So this is a simple example. Okay, will this work? Let's see. Print using matrix printer bill number one. Fine. So let's go back here. Okay, so you have a design where you are, where everything is working fine. Now, what is the problem with this? The problem is, suppose you want to now, replace the matrix printer with the laser printers everywhere in your system. You say that matrix printer is outdated. I want to use the laser printers. So what you have to do in this system? So what you have to do is, you'll come here to the invoice generator, you know, remove the old code, and you will have to write a new code for the new, system. Laser printer will print bill details. Just print invoice, bill details. Will it work? Definitely, it will work. Print using laser printer bill number one, right? But what was the problem with the system? This invoice generator should not have been concerned with what type of printers you are using or what font you have, these kind of small details, what printer you are using and all those things, because it is a high level module. Printers may change. Billing is my core feature here. So that is, something that I changed because my higher level module was dependent on the lower level module. It was dependent on the type of printer. So this is something which the dependency inversion principle says you are not supposed to depend on the lower level modules. The lower level modules can depend on the higher ones. So in this example, the invoice generator being a higher level module was dependent on the matrix printer or laser printer being the lower level modules. So what solution we have? Solution is to add a layer in between them. So kind of interfaces or abstractions so that you don't have to directly interact with the lower level module. So suppose I have a I have a new interface here, add a new interface here that says print invoice. It will take uh, a string. I'll just write bill details, right? And it will print it. And what I'll do, I'll make matrix printer use iPrinter, and the laser printer also use iPrinter, right? Now what I'll do here, okay, yeah. So here I will have a constructor, mhm, which will initialize my generator. Okay, so what I will do, I will take my interface iPrinter. I have a read-only interface printer. Okay, iPrinter printer. Just for simplicity, I'll make it like this. And what this will do, this will take a this will also expect a printer, and what I will do is I will assign my printer with whatever printer type or the printer that is coming from the object creation, which we'll be seeing just now in a while. So this is what I have done. Now generate invoice should simply make use of this printer dot print invoice. It doesn't care who will be doing the printing, what is happening in the background. It will simply use this object and do the printing. Right? Now let's go back to where we are calling this. Okay, so first of all, here you see this error because it's a constructor. It is asking for an argument, right? So let's just give it an argument. So we need a printer. So in the old scenario, we have a matrix printer, right? We'll have a matrix printer and we'll pass this matrix printer here, matrix printer here, right? And we'll have this object. Now let's see what happens. So it is printing using the matrix printer. Now suppose the organization comes and says, no, you are not supposed to use the laser printer. So what you do? Matrix printer, you are supposed to use the laser printer. So what you do? Your higher level module, you don't change anything because you don't need to change anything. The lower level module changed. Simply come here, you change the object of this laser printer, pass this here because whatever going here is a printer, right? So it doesn't matter what you are doing to the higher level module. It doesn't matter anything. It simply knows that the printer is coming and you're using a laser printer to print. So in our example, now what is happening after we resolved the dependent, after we implemented the dependency inversion principle, the invoice generator, which is a high level module, is not having any change even after the lower level modules got impacted, right? So this is a very simple example of dependency inversion principle. This is something which you will come across when you will work on an enterprise application. You try to notice these things in the system that you are currently working, or in future you will work on, or in future when you create new systems. Keep this in mind and your code will be good. It will be following all the basic principles if you take care of these small principles, and if you take these things seriously in your day-to-day coding life. So that's it for today. Keep following this space for more discussions. And this is Devlov signing off.